Is the line 3, 0, 9, 2 plus s, negative 1, 3, 10, 1 perpendicular to the hyperplane negative x1 plus 4x2 plus x3 minus 3x4 equals 6. So we can test perpendicularity of a line to a plane or a hyperplane or even another line if we're in 2 dimensions by checking to see if the direction vector for the line is a scalar multiple of the normal of, in this case, our hyperplane. So we can see our hyperplane, negative x1 plus 4x2 plus x3 minus 3x4 equals 6. And we can see there is a normal vector, negative 1, 4, 1, negative 3. Okay, so that's our normal vector. We need to see, is it a scalar multiple of the direction vector for the line? Can I find some c so that this normal is a scalar multiple of negative 1, 3, 10, 1? Okay, so, well, if it were the case, if we could find a single value of c that did this, we get negative c, 3c, 10c, and c here, and that would need to be equal to negative 1, 4, 1, negative 3. And so we get a series of equations. The first components have to be equal. So negative 1 has to be negative c, or rather c has to be 1. But if this is true, then we also need 4 to be equal to 3c. But then that means c has to be 4/3. We've got 2 different values of c, so already we could stop and say no. The normal vector for our hyperplane is not a scalar multiple of the direction vector for our line. And so no, the line is not perpendicular. Now, for those of you who want a little more practice testing if things are scalar multiples, what would we also need? We'd need 1 to be the same as 10c. But then that means c has to be 1/10, yet another different value. All it took was 2 values that were different. Or negative 3 equals c. Well, that's yet a 4th different value. Okay? So this normal vector definitely not a scalar multiple of the line's direction vector, and as a result, the line is not perpendicular to the hyperplane.